Alright, hello. So, as you know, we're going to be continuing the 2024 Beaver Computing Challenge, grades 7 to 8. This is, again, part 2. If you weren't here for part 1, I'll put a link for that in the description. We will be doing questions from 6 to 10. We already did all these questions, obviously, before. And, yep, okay. Yep, we did this, did the marching garden. Part B. Super Bebras. In the computer game Super Bebras, the background and the illusion of motion is created using a sequence of tiles. Tiles added to the right end of the sequence are chosen according to the rules in the diagram below. Arrows point directly from each tile to the only tiles that can be added immediately to the right of it. For example, a tile to the right of like a brick can only be tiles brick and a blank. Which of the following images is not a possible Super Bebras background? I'll give you a minute to think. Pause the video. Alright, you're back. So, this is a simple, just look at what we have and just work based off of that. Okay, so let's start with this one, right? We have a blank, okay? Next, we have this, which as we know can happen. After the diamond, we have a blank. That can happen. After a blank, we have a brick. That can happen. After a brick, we have brick again. And that can happen. And after a brick, we have a blank. And that can happen. So obviously this one is correct. But they're saying is not a possible. So let's look at B. We have a diamond. Okay, we're starting from here. We have a blank. Okay. Then we go back to diamond. Okay. And then we're jumping to a brick. There is no line that goes like here. So we know that B is the correct answer. As you can see, that's correct. Okay, logs and branches. The sequence of logs and branches are represented by codes using the following two steps. Moving from left to right in a sequence, each log or branch is represented by the number of branches to the right of it in the sequence. This gives us a sequence of numbers. Then each even number in the sequence is replaced with a 0 and each odd number with a 1 to obtain its code. Let's look at the following sequence as an example. The leftmost log has 3 branches to the right of it, so it will be represented by 3. The next branch has 2 branches to the right of it, so it will be represented by 2. The next branch has 1 represented to the right of it, so that will be represented by the 1. So continuing the sequence gives us 3, 2, 1, 1, 0. So its code is 101110. Now, what we can see here is, okay, let's look. So which of the following sequences of logs and branches is represented by the code 111010000? What we can do, right, is we can look at this last 3, 000, right, which would be represented by this, this, and this. Now this log supposedly has 0 to the right, but it has 2, so it's not A. This branch supposedly has 0 to the right of it, but it does, so it might be this one. Same with this one. And this one has 1, so this is also incorrect. Now we're left with B and C. And this is just a matter of choosing, is it log first or branch first? And obviously, a log would mean that there's 1, 2, 3, 4. 4 is an even number, and they said even numbers are replaced with a 0. So all these even numbers, so that would be replaced with a 0. But as you can see, it starts with a 1, and we have a resulting answer as B. wait, hold up. I'm just kidding, it's C. Because B has 4, which would make it 0. Yeah, it's C. Sorry about that, guys. Okay. Now, after my silly error, we can move on and look at spices. Gennaro uses his balance scale to weigh the spices he sells. He uses only the following 5 weights on a scale: 1 gram, 3 grams, 9 grams, 27 grams, and 81 grams. Gennaro always puts the spices on the right side of the scale. Now, this is really important, so just let me highlight it. Okay. To measure the 11 grams of spices, he places his weight as shown. As you can see on this side, it's 3 plus 9, which is 12. And on this side, it's 1 plus x. 1 plus x would obviously be 11. To help train his new employees, Gennaro creates codes for different amounts of spices. In his code, L means the weight is placed on the left side, R means that the weight is placed on the right side, and O means the weight is placed off the scale. Gennaro writes each code from smallest weight to the largest weight. For example, the code for 11 grams of spices is RLLOO, as shown, right? Which of the following 4 codes which measures the heaviest spices? Now let's look at A. Left, off, right, left, off. So that means this would be left, off, right, left, off. Now on the left side, we have 1 and 27. On the right side, we have 9 plus x. On this side, we have 28. And on this side, we have 9 plus x. So 28 minus 9 is 17. Okay. Now we have right, 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 left. So that means 1, 3, 9, 27. 81, right? And that would be 1 plus 3 is 4. 4 plus 9 is 13. 13 plus 27 is 40. Okay, 40 plus x. Oh my, that's a whopping 41, which demolishes the first. Now we have left, right, left, left, off. So we have 1 plus 9 plus 27, and then we have a 3 here. 27 plus 9 is 36. 36 plus 1 is 37. 37 minus 3 is 34. And finally, we have off left, right left, off. Left and left, so that's 3 plus 27, which is 30, minus 9 wouldn't make the cut. So your answer is B. As you can see, it's right. Online class. 9 students are sitting side by side in one row in the library while their teacher conducts an online lesson from her home. The teacher sees the class on her laptop screen as shown. Each student is using a different computer, but the teacher's screen shows who each student is sitting next to. Which student is sitting in the middle, the 5th position of the row in the library? Now, obviously, we have to look for the one that has no one sitting to the left of him, and that we get James. James is sitting in first. Now, James, we have Elkie. Next to Elkie, we have Diana. Next to Diana, we have Lee. And next to Lee, we have Hannah. And sitting in the 5th position is D. Last question, I'm pretty sure. Yep, last question. Okay. Collecting dolls. Beaver Dana enters the maze below carrying a doll size of 1. She then goes through the maze and collects dolls of different sizes, placing smaller dolls inside larger dolls. What is the maximum number of dolls? Diana follows the arrows and obeys the following rule when she encounters a different doll. If the doll that she encounters is bigger than the biggest doll she already has, she can choose to either take the doll and place her dolls inside of it or leave it behind. Otherwise, if the doll she encounters is the same size or smaller than the biggest doll she already has, she must leave that doll behind. What is the maximum number of dolls that Diana can collect, including the size 1 doll, by the time she reaches the exit of the maze? Okay, so this one you can just try different paths, right? But if you the answer path would go here. Oh, just give me a sec. One second, I don't know what's okay, yeah. Just go over there. Okay. So you go over there, 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 and there. The reason this works is because you pick up 1, then you get the 2. You have to skip this 5, but other than that, you can get the 3, 5, and 6, which would get you 1, 2, 3, 4, 5, which is 5. There's no other path to get 6, and C is your answer. Thank you for watching, and stay tuned for part C.